So in this lecture we will study about a term that is called as market basket analysis. So we are learning this term for mainly doing unsupervised learning. Okay, unsupervised learning. So what is unsupervised learning? Unsupervised learning means you have only the inputs, you don't have the outputs. So by using the inputs you have to find some patterns from it, means cluster it or group it like that. Okay, that is called as unsupervised learning. So in unsupervised learning, a mining method is there that is called association rule mining. Okay, so what is association rule mining? Association rule mining finds it has some rules, it finds some patterns, okay, in the inputs to classify the inputs from each other. Okay, so for that we are taking an example that is called market basket analysis. Okay, so in market basket analysis, okay, what we are doing, we are taking a supermarket case where many customers have many types of transactions by taking some items. Okay, so from getting the information of the transactions, what the items they are taking, we can find what are the patterns. Means suppose a person is taking bread, means he will take milk also, and suppose a person is taking onion and potatoes, then he may take chicken or meat also. Okay, so this type of example can refine our supermarket so that we can give a good efficiency and good efficient service to the customers. Okay, so that our model will be morely predictable and according to the scenario, okay, or the current trend. Okay, what items I am buying, so that items we will keep in the supermarket. Okay, and providing good service to the users or the customers. Okay, so we have to find mainly the patterns from the transaction history. Okay, so for that we have taken a supermarket transactions. Okay, so here one thing is important, that is X. Suppose X is a transaction. Okay, if I am buying X, then I am also buying Y. So this is a rule. Getting? So this is a rule that X, if I am buying X, means I am buying Y. So I can make it a rule like X arrow Y. So this is also called a transaction where X and Y are the items. Getting? So and here X is called as antecedent and Y is called as consequent. Okay, and in this model we have a set of items I, that may be I1, I2, okay, then I3, like that IN, and we have a transaction history that may be represented as T1, T2, T3, Tn. So getting? So these are the basics of market basket analysis. Okay, so from so in this lecture we will take a problem, okay, and solve it using some parameters. Okay, so association rule mining has some parameters, okay, by which by using the parameters, okay, we can find the patterns. Okay, first of all we will go through the parameters of association rule mining. So let's study the parameters. Okay, so here the first parameter is support. Okay, so for that, okay, support. So what is a support here? Okay, so support is an indicator of how frequently the data items appears on the database. Okay, so this is called as a support. Support means actually the frequency of the rule in a transaction history, that is called support, and we can represent support of item X is equal to T belongs to T. Okay, X is a subset of T by T. Okay, so here it is called as the frequency of items. Suppose now we will solve a problem. Okay, that is I am giving a transaction, okay, history. You can see here, okay, this is the transaction ID. Okay, so I will do 5 transactions here. According to here, milk is there, okay, then bread is there, okay, then butter is there, then beer, okay, and the last one is diaper. Okay, so these are the transaction IDs 1 2 3 4 5. Okay, they may be it may be a we are assuming that each transaction is done by customer 1, like customer 2, like customer 3, like customer 4, and like customer 5. Okay, so here we can see like I am giving some values 1 1 0 0 0, then then our 0 0 1 0 0, then 0 0 0 1 1, then 1 1 1 0 0 0 1 0 0 0. Okay, so here 1 means successful, 0 means not successful. Means you have buyed an item, you have not buyed, and here you have buyed. Getting? So from this example we will find the support. Okay, so suppose I have this example of like X is equal to beer comma butter. So I have to find the weight of beer comma butter or the frequency in this transaction history. So you can see that beer and butter, beer and diaper. So beer and diaper. So we have to find this beer and diaper. So here you can see beer and diaper are in this case. Okay, so the frequency is 1. Okay, so how many transactions are there? The value of T will be 5. So the value of support will be 1 by 5. Okay, that will be 0.2. Getting? Suppose the value of X is only milk. Getting? Then only milk, you can see 2 times milk are there. Okay, milk 1 and 2, then 2 by 5, that will be 0.4. Like the same, if X is equal to butter and beer, then what is the value of support? So butter and beer, you can see nowhere, butter and beer, so the value will be 0, means 0 by 5 is 0. Getting? So this is the example of support, means what is the uh, support of an item in the transaction history. You are finding that. Okay, so another term we will see. Okay, another parameter like the same another parameter is there. Okay, that parameter is called confidence. So what is confidence? Confidence is the indicator of how often the rule has been found true. Means you are finding a rule that if a person is taking milk, means he is taking bread also. Okay, like the same. So what is the confidence of that rule that he will take milk, means he will take bread also. So that can be represented like CONF, confidence X on Y is equal to support X union Y by support of X. So here we have to find support X union Y by support X. So for example, I am giving, okay, like butter comma bread. Okay, so butter comma bread. For example, X gives butter and bread. So what is the confidence of X and Y? So I have to find, okay, X union Y. Okay, so X union Y means what? Can you say? What is X union Y? Suppose I have given butter and bread. Okay, so if I am taking butter, means I am taking bread also. So what is the support of X union Y? So X union Y, we can see that bread and butter. So here we are getting 1 1. Okay, you can see. So 1 1 we will take the support as 1 by 5. Okay, and the union of bread and butter. Then the support of X only. X means what? X means the butter only. So butter appears, no sorry, okay, that will be 1 by 5. Okay, so the value is 1. Okay, so you are finding of only X item. Okay, then the union of the item. So union means two items are in the same set, and you have to find the value of X only. Getting? So this is called as the confidence, butter and bread. Okay, so 1 by 5, 1 by 5. Okay, if I am taking butter, then what is then I will take bread also. Okay, so this is called as the confidence. Then we will go for another parameter, that is lift. Okay, so what is lift? Okay, I can represent a lift value like this. Lift X on Y is equal to support X union Y by support X into support Y. Okay, lift is a measure, and let's we will take another parameter, that is milk comma bread. Okay, will give you butter. Okay, so in the previously we have solved a problem, that is confidence. So there we are taking butter bread will give rise to milk. Okay, there you will feel a doubt that how I find 1 by 5 by 1 by 5. Okay, so there we are taking butter comma bread will give rise to milk, and you will find 1 by 5 by 1 by 5 is equal to 1. Okay, that is clear. Okay, then in the second part we are seeing that milk bread will give rise to butter, means this is the x part and this is the y part. Okay, and if we will solve this by using this equation, x union y means milk bread butter are in this case milk bread butter. So what is the support for that? 1 by 5 by support of x and support of y. So what is the support of x? Milk bread. Here we are getting it, here we are getting it, milk bread. So 2 by 5 into only butter 2 times, so 2 by 5. Then what we will get? The answer will be 1.25. So this is called as the lift, 1.25. Okay, so from here we have to decide what is the lift. Okay, so I am saying a rule, that is rule 1 says that if the rule had a lift of 1, okay, then if the rule has a lift of 1, then it would imply that the probability of occurrence of the antecedent and that of the consequent are independent of each other. Okay, then what says rule 2? Okay, if lift has the value of L greater than 1, okay, that lets us know the degree to which those two occurrences are dependent on one another, and makes those rules potentially useful for predicting the consequent in future data sets. So this depends on the degree of dependency. Rule 2 says the degree of dependency. Okay. So here we have solved the parameter lift. So you know, if L is 1, that means that they are independent. In L is greater than 1, that means that how much dependent it is, the two parameters on each other, like x and y. Okay, then we will go for another parameter. Okay, that is conviction. Okay, so what is conviction? So conviction can be represented as CONV, convic x on y is equal to 1 minus support y by support of y by 1 minus confidence of x on y. Okay, this is very easy because we can find support, we can find confidence also. And if I am going for milk, okay, then bread, this is example. Okay, milk, bread and butter, means this will imply butter, means milk bread, this is the x part and this is the y part. Then I will get like this 1 minus, okay, so this conviction can be calculated as 1 minus 2 by 5 by 1 minus 1 by 5 by 2 by 5. Okay, that maybe the answer may be 1.2. okay, you can check it. Okay, so this is conviction. So what conviction says actually? Okay, so this shows that the rule would be incorrect 20% more often. Okay, 1.2 times as often. Okay, if the association between x and y was purely random choice or chance. Okay, getting? So these are the 4 parameters, okay, by which we can find patterns in a transaction history. So later we will see, okay. After this we are going for finding the support and finding the frequent items, okay, the frequent items in a data set, okay. So let's go for it. So in association rule mining, okay, we have a very important algorithm that is called as a priori algorithm, okay, a priori algorithm. So what is called as a priori algorithm? A priori algorithm is mainly used to find the frequent patterns in a data set, okay. Means in the supermarket we have to find the frequent items, means which items the customers are frequently buying. That is the main problem. For that we require support. So it is very easy, okay, to find the frequent patterns. So let's solve the example, okay. So I have, suppose, a transaction history, okay, I am giving, okay, let's see, okay, this is transaction history and these are the items, okay. Let's draw it first. Okay, let's the transaction 1 2 3 4 5 6 7, then the item sets are 1 2 3 4 1 2 4 1 comma 2, then 2 comma 3 comma 4, then 2 comma 3, then 3 comma 4, then 2 comma 4, okay. Let's in step 1 what we are doing in step 1, okay, calculating the support for the single items, okay. Means first of all the first step is to find the frequency of the single items, means 1 2 3 4, okay. And always a priori algorithm has a threshold value, okay. Here the threshold value is threshold value is 3, okay. So what is the threshold value? Threshold value means the customer has to buy these items at least 3 times, okay. Else it is unpopular item, means we have to find the popular item. For that we have set a threshold that it will also be 3 always in the transaction history, okay. So if I have a table like this, okay, of the items, okay, so here item is there and here your support we can see that 1 2 3 4. So what is the support here? 3 6 4 4 then 5, okay. So these are the frequency of the items when it is single. So here we can see that each item is equal to 3 or greater than 3, okay. So all have passed it. So we have to keep these items, okay, in our store 1 2 3 4, okay. But we have to find the frequent pattern, okay. So what are the patterns we have to find? Because singly they are enough, okay, singly they are enough, but we have to find the patterns for them, okay. So in singlet they have passed the threshold value, and what we will do in step 2, let's see. So in step 2 what we are doing, we are finding the for doublet, okay. We are finding frequency for doublet. Okay, for the double items, let's pair the item. Okay, like pairing it. Okay, then what is the support? Okay, so you have to uniquely pair it. Suppose we are pairing 1 comma 2, means that you should not have 2 comma 1. Okay, because the two items are same only. Getting? So 1 comma 2. Okay, like the same 1 comma 3, like the same 1 comma 4, like the same 2 comma 3, as same 2 comma 4, then 3 comma 4. Okay, so what is the support here? Support will be 3 1 2 3 4 3. So you can find it here in this data set. 1 comma 2 means you can say 1 comma 2 1 comma 2 1 comma 2 means these items are 3 times, so it will qualify for the next round. And so here you can see that 1 comma 2 means if a person is buying 1 means he is buying 2 also. That means that. Okay, so here you can see that it is less than the threshold value, so you have to prune it. So what is pruning? Pruning means you have to deleting the item, deleting the items. Okay, so you have to do a pruning process here. Here it is pruned, here it qualifies, it also qualifies because they are greater than 3. Okay, so we have pruned 1 comma 4 and 2 comma 3. Okay, so here we have to understand a thing, that if in future, okay, if a combination of 1 or 4 exists in a triplet, okay, after this we will pair the triplet. Okay, 1 2 3, like 3 to 4, like that. Then if a combination comes like 1 comma 4 or 2 comma 3, if this exists in a triplet form, then that total set of triplet will be cancelled or pruned, because these values are now so these values are, sorry, not this one. Okay, so these values are pruned in the previous step, in step 2. That's why they will not float to step 3. Okay, when suppose a combination is there like 1 3 4 in the triplet form we are going, okay, then they are not counted, or because they are already deleted here, its subset is deleted here, because 1 3 is in 1 3 4. Okay, suppose 1 4 2 is there, means 1 4 is already deleted in step 2. That's why we will not take 1 4 2. Okay, this is the main funda here. Okay, so we have to go through this. Okay, so here we are seeing that 1 comma 2 2 comma 3 2 comma 4 and 3 comma 4, they have qualified this. So we know that if a person is buying 3 means he will buy 4. Okay, so let's go to step 3. So in step 3 we are finding frequency for triplet. Okay, so here we can make a combination there, 1 comma 3 and 1 comma 4. In the previous round 1 comma 3 and 1 comma 3 are pruned. Okay, are pruned. The pruning is done in this, means we have deleted these items. Okay, because they have not qualified. That's why we will not go for this combination, and only one combination left, that is 2 3 4. So here you can see that 1 3 is not there, 1 4 is not there, but it is a combination of 2 3 4, and we in triplet we find that what is the support for it, 2 3 4. You can see 2 3 4 in this part only, 2 3 4, and here 2 3 4. So the support is 2, means this will also not qualified and this will be pruned in this round. Okay, it is less than 3, that's why it will also get pruned. Getting? So what are the frequent items we have generated till now in singlet, doublet and triplet? So what are the items? That items are 1 2 3 4, then 1 comma 2, 2 comma 3, then 2 comma 4, then 3 comma 4. So this is the answer, and these are the frequent items using a priori algorithm. So now this is over, and I think you all betterly understand this concept, that is a priori algorithm. So used in the supermarkets to find the frequent patterns in a transaction history. So thank you.